Welcome to another Gibbs Cam version 14 video. Today we're going to show you a little bit about MTM on an Okuma. This machine here is an Okuma LT2000EX that has two turrets and two spindles, an upper and lower turret and a main and sub spindle. So we're going to go through this. It's a simple part. We're not going to do any milling on this. This is just simple turning just to give you an idea how to program the machine. Here I have my solid model on my main spindle, and it's already oriented correctly. I'm going to show you the coordinate systems that Gibbs automatically creates for you when you have this type of machine. So you have ZX, XY, YZ on the main spindle and the same thing on the sub spindle. And of course you can create more coordinate systems as you need to for milling, etc. So we're going to go to the ZX plane. This is our turning plane, and the first thing we want to do is extract the geometry. Now normally I turn off the sub spindle till I'm done finished programming the main spindle, because when you hit no zoom it shows you the main and sub. Sometimes I just want this to zoom up, so I'm just going to go to part stations and actually turn off the eye on the sub spindle. Now when I go to no zoom, you can see it just shows me the main spindle. So I'm going to open my document page here, and we're going to fill in a few blanks here. First I'm going to start with the main spindle. This material is 2 inches, and I have it sticking out of this main spindle 2 inches. So it's around this location here. I want to part off and leave 10 thou on the main spindle as well as the sub spindle, so I can face it off because we're going to do a bar feed, initial bar feed, and pull with the sub spindle for each part. I put in 8 inches in here. Our part's only 4 inches long, but I want to see the bar when I'm parting off and going to the sub spindle. Of course, I'm programming in inches and diameter, and this is our clearance here, 2.1, because our material is 2 inch. So these numbers always have to be larger than these two numbers, because this is where the tool is going to wrap it to before it goes home, does a tool change, or go to the next operation. So you want those to clear your stock. I'm going to say this has initial stock, and it's already preloaded in the main spindle. Now this graphic part face distance, if I uncheck that and I was to turn on my sub spindle, you can see that's the distance between the spindles, main spindle and sub spindle. So that can be like 20-30 inches depending on your machine. So let me turn this back off. So what I'm going to do here is I'm going to say graphic part face distance. This is a pretty short part, only 4 inches, so I'm going to say 8 inches in between the spindles there. And this is only a graphic distance on the screen, not what the actual machine is. So this will have no effect on the actual G-code output on this machine. This just helps you in the programming side. Now we also have a go back to main spindle here. Graphic part face, same thing there, initial, loaded, all these are good here. And you have an upper and a lower turret on here, and you want to make sure these are both the same for both of them here. We'll deal with the sub spindle when we get to that section here. So I'm going to unzoom this a little bit. I'm going to select my solid. I'm going to go to this drop down menu that says, bring it up here. Come on, my notes. This is spun geometry. My note's not popping up. I don't know why. But let's just select that geometry, right click, and extract the profile. Now I don't necessarily have to extract the profile, but a lot of times I like to put dimensions and things on that just so I can see where everything is. So while we're at it, let's put some dimensions in here just so we can see what they are. Of course, that 0 there back here is Z minus 1.25 inches. Back to here is 2 inches. Let's just do them all at the same time. And here I have a lot of dimensions here. You can get rid of things you don't want, or you can do one at a time. This is just a global dimensioning if you want to do it this way. So there's a couple ways to do that. Okay, I cleaned this up just a bit to show you just the dimensions I really need for this. Of course, Z0 here, the diameter here is 1.5 inches, of course, 2 inches here. 1 inch diameter on the back side, and of course, like I mentioned, 4 inches back on the Z. So let's just turn these off for now. So the next thing I want to do, I just want to load up the tools for this machine. So I'm just going to right click and load the tools. And there's my tools. Just some simple tools. These are going to be for the upper turret, basically the main spindle. So I have my upper turret here. You can see upper or lower turret, and you can choose the positions here. It knows how many positions there are on this machine, and that will change depending on the type of machine you have. And our offset number, and I always give it a comment there so I can look at the G code to see if it's main spindle, sub spindle. This just helps when you're looking at the code. And of course, 55 degree to finish. I'm going to put my part off tool at the upper turret. You can decide upper or lower turret, and some of that depends on the manufacturer, which turret they like you to part off with, and that depends on the machine tool sometimes. Some will let you do both upper and lower turret. So on the lower turret, you can see I have another 80 degree diamond, lower turret position 1, and 55 lower turret position number 2. Now you can decide whether it's insert face up or face down. This is going to change your spindle direction for what you want to do. I just have them facing up right now. So the first thing I'm going to do, turn on my cam, is just face this off just in one pass. So I'm going to create a turning contour with the 80 degree diamond for the upper turret. We're going to do a front face, rapid to 0.1, it's all good. I'm going to do a 50 thou 9 degree line, and I'm going to leave 3 thou stock on here. You can see you can use your regular coolant or high pressure, either one you'd like. I'm just going to put maximum RPM, possibly we'll just say 2,000, 600 surface feet per minute, and 10 thou feed rate, because we're just going to rough this out and leave 3 thou on here. So just going to click on here. Bring my marker out to the past the 2 inches there, and I'm going to snap this to X0 Z0. Now Gibbs will automatically go below this when it faces off to account for the tool nose radius, so you don't have a little island there on the end. So we'll click on do it, and that is finished. Now the next thing I want to do is rough this out, so I'm going to use the same tool, but I'm just going to right click and say change the process to a roughing process. Bring this tile over. Again, an OD. My stock is, or my wrap is 2.1, and our stock is 2 inches. I'm just going to do a 50 thou depth of cut, and I'm going to leave stock XR, which is radius stock, 5 thou, which will leave 10 thou diameter, and again 3 thou to finish up here. Maximum RPM, I'm going to do 2,000 again. You can always use the material database here, and you can modify this as you need if you have cut data. So everything looks pretty good there. Again, I'm going to click on the chamfer, go off my part a little bit. If you want to go a specific distance, you can always right click and say move the start end point by 100 thou if you want, whatever you'd like to do. Hold the control shift down, click on the last item you want to cut. Now since our stock is already here, there's no need to go clear back to here, so I'm going to end at this tangent point here. Click on do it, and there I have my roughing process. Now I want to come back and take a finish process on this, a finish pass starting with X0 and go up and over. I'm going to clear this out, do a contour with the 55 degree, do an OD. I don't want to wrap it at 2.1 and feed down, so I'm going to say rapid to 0. Now we are going to take a finish pass on this part, so I'm going to clear this out, put in a contour along with our 55 degree. I don't want to wrap it to 2.1 and feed clear down, that's a waste of time, so I'm going to wrap it to 0, and of course Gibbs will modify that slightly to allow for the tool nose radius to go below the surface there. And I'm going to do 50 thou again, so I'm going to come down 50 thou, then go in, then back up. I don't want any stock, and change our surface Surface feet's okay. We'll change this to 2000 though, and we'll change this to 6 thou, low pressure. Okay, I'm going to start now on this face. I'm going to start at X0, and I'm going to go up, Control Shift again to the last thing I want to cut. I don't want to cut down here or here. I want to end right at this radius tangent point. Click on Do It. All right, now we can do a cut part render to see where we're at and see what it looks like so far. Turn on our cut part render. Slow it down a bit. So we're going to face off a little bit, about 7 thou, and then we're going to back face that with the 55-degree tool. And so far, this is what we have. Looks pretty good. So let's continue on. We're going to clear this out. Next, I want to do a utility right here with the part off tool. And I'm going to get the upper turret out of the way before the sub spindle comes over. So I'm going to do a move tool group, which is going to move the tool. And it's going to, since it has tool number 3 in there, the part off tool, I'm going to say go to the main spindle, new location, nothing on XR, but on the Z, I'm going to put a user, and I want it to go 10 thou in front of Z0, which is right here. I want to do it by the part ZX, not the spindle, but the part ZX and the tool tip of the tool. So I'm going to click on Do It. That's going to move the turret out of the way for the sub spindle to come over. Of course, you could do that with the lower turret as well, but the post should automatically put in that already. So now we need to do utility again. This time I want the sub spindle to come in. I'm going to wrap it a 1/2 inch away from this Z here. Feed rate 20 inches, and I'm going to highlight this and hold the Alt key down, click on this point here, and it says it's -1 1/4 inches, which is fine. This is where I want to grab onto. Spindle speed of 500 RPM. Now I really don't need the C's synced because I'm not doing any milling on this for the main and sub that need to be synced up. But even this being unchecked, both spindles will rotate at the same RPM. I'm going to have spindle on because we want the air blow on to blow the jaws off as on the sub spindle before it comes over, so we don't get chips wedged in between the chuck jaws. So let's click on Do It. Okay. Now we're going to do another utility again because the sub spindle already came in and grabbed this part. So this time we want to do a part shift because we're going to shift the part now because we want to pull the part out enough that there's another piece here ready to go when the part is finished and it comes over to do another part. So we're going to go 20 inches a minute, and to figure the shift distance, so you put in the overall length of the part, which is 4 inches, plus the part off tool, which is 1/8 of an inch, plus how much stock I want to leave on the main and sub spindle, which is 20 thou, 10 thou on each one. And we end up with 4.145, spindle RPM 500 again. Click on Do It. So the next thing I want to do now is part off the part. So I'm going to clear this out, bring a contour in with the part off tool. OD again, 2.1, because this is going to be raw stock that we're going to part off. I don't want to do an entry and exit line because we don't want the tool to be wedged in between there and snap off. Z, again, we're going to leave 10 thou stock, and usually part off, I usually start about 3 thou is a good place to start. Now you can use high pressure if you like on there as well, and we'll click on bring our part to the OD there, down, and we want to part off right at X0, Z0. We're cutting down. Now make sure you click the cutoff button here so Gibbs knows that you're actually cutting it off. And click on Do It. So that should have our part off. And then we're going to bring the sub spindle home. So I'm going to bring up another utility. No tool this time. And I'm going to go Sub Spindle Return. with the sub spindle on again, 500 RPM. I'm not going to open the main collet because remember we still have material in there. So click on do it. Okay, so now we have the part finished in the main spindle and transferred over to the sub spindle. So let's turn on the sub spindle for now, and let's take a look and see what we've done. So let's turn on cut part render, rewind, and let's click play. But before we click play, I'm going to turn on this stop sign, say stop before you unload or load or basically transfer to the sub spindle. So we're going to play this out. We'll speed this up just a little bit. Okay, so far so good. Now we're going to single step it through. So the sub spindle comes forward, grabs the part, pulls it. Now the part off is going to come in and part off. Then the material is going to move to the sub spindle. And now it's in the sub spindle. So what you're seeing in the sub spindle is everything you machined on the main side. If you had milling and drilling, things like that, you would see that also over here if you did that there. So now we're ready to start programming the sub spindle, but we need to move our part over to the sub spindle. This is just a rendered image. This isn't our part over here. So let's turn off cut part render. I'm going to turn off cam for the moment. And we're going to transfer everything over to the sub spindle. So let's click the geometry and click our solid. And this time I'm going to do modify, duplicate, because I want to duplicate it and translate it. Let's move this up out of the way here. Okay. I'm going to just do a translate, the Z. Remember we have, if I look at my document control, 8 inches between the spindles. So I'm going to move it 8 inches, and our part is plus 4 inches plus 20 thou. That should be 12.02. Don't want to move anything in Y, so we'll zero that out. Click on do it. Now we have our part transferred to the sub spindle. Now all we did here is really move our part and duplicate it over 10 inches or so, 12 inches over to here, but we didn't tell Gibbs that this is actually supposed to be in the sub spindle. So when I click on the solid, you'll see the both highlight there, so we want to separate those by going to the solid model and clicking separate. Now these are separate models, as you can see. Now we want to tell Gibbs everything on the sub spindle here, or everything over here should be in the sub spindle. So I'm just going to highlight everything here. Go to my coordinate systems. This is my sub spindle. I'm just going to click on that, right click and say change everything over here to the sub spindle. Now you can see everything on the main spindle now is purple and everything is blue over here on the sub, which tells us this is in this coordinate system here. If I went to this coordinate system, the main spindle, you can see everything over here is purple, which Gibbs is telling you this is in a different coordinate system or the sub spindle. So let's go back here. So now we can start programming the sub spindle. Now if you like, you can actually turn off the main spindle if you want, so when you click no zoom, it just zooms up the sub spindle. So that's up to you. We'll just keep it on for now. So I'm going to turn my cam palette back on. I'm going to clear this out, and again I'm going to do basically the same thing we did on the main spindle. I'm going to bring up a contour first with the 80-degree diamond on the lower turret. And again, we're going to do a front face. Make sure you click on sub spindle. Everything else should be about the same thing here. I'm going to put 50 thou there. I'm going to leave 3 thou to back face on there. 10 thou to face off. Everything looks good, except one thing you want to do is click other side. I'll show you what it does if you don't. So we need to face this off, again, just like you would on the main spindle. And right here at X0, Z0, click on do it. Now if you look, you can see it's on the wrong side, and you can see the rapid lines going to the lower turret, which is not what we want. So make sure you click on cut other side. We'll redo that. You can see now it's on the lower turret other side, so that looks pretty good. Now again, we're going to rough this out, so I'm going to change the process to roughing with that same tool. Everything else here should be about the same as it was on our last part we did on the main spindle. And again, I'll start on the chamfer here. Let's move it off a little bit here, cut this direction, Control Shift, and I'm going to end right at this point here. Click on Do It. Now you can see it didn't like that because we didn't do Cut Other Side, so we'll always make sure you click Cut Other Side if you're working on the lower turret. Click on Redo, and you can see now it does this on the opposite side of the lower turret. I'm going to clear this out now, bring in a contour to finish with the 55-degree lower turret. Again, OD, cut other side, sub spindle. Everything looks pretty good there. Zero out the stock. Change this to 6 thou. Again, I'm going to click on this face. I'm going to start at X0Z0, go up, because we're going to back face this. And I'm going to end up on this contour and off the part just a little bit. Click on Do It. And you can see this part is done. Now let's go to let's unzoom a little bit so we can see both spindles. And let's do a cut part render. Okay, turn on cut part render. We'll display it right from the beginning. We'll turn off geometry and play. There's the main spindle, stops, single step. I'll just single step it through. There's our part off. Now let it play on. Go to the sub spindle now, face off, turn the OD, leave stock and come back with a 55-degree to finish, and you're done with the sub spindle. Now, one thing you want to remember when you're doing a dual turret, dual spindle machine is that you don't want to finish everything off on the main spindle, then transfer over, then finish off the sub spindle. Otherwise, you have everything sitting idle on the sub spindle when the lower turret can be over here doing something while the upper turret's doing something on the main spindle. So we need to make sure these are both running simultaneous here so you can have a real efficient part. So the upper turret will be cutting the main, lower turret will be cutting the sub. So one thing we want to do on here is sync everything up, and we want to make sure we have a part in the sub spindle when we press cycle start. Then before we transfer, we'll make sure the sub spindle drops the part out, and then the sub spindle comes forward, grabs, and does its part. So first, I'm going to turn my cam back on. And I'm going to separate these into flow 1 and flow 2. You can see they're all together right now. But if I go to any operation, right click, and say sort the operations, it's going to sort them into flow 1 and flow 2. If you have a 3-turret machine, of course, it would separate into 3 flows. So this is everything that's happening with the main spindle or upper turret. That'd be flow 1, and then lower turret here, flow 2. So we're turning here, as you can see. Then the part off tool, sub spindle comes forward, does a part shift, part, and sub spindle return. And it shows basically the same thing here on the sub spindle, but we need to change some things around. We want to machine everything on the sub spindle before the sub comes up to do a part transfer. So I'm just going to take these 3 tiles here and drag them below here, and let's do a cut part render and see what it looks like right now. Turn on our cut part render. You can see the lower turret is cutting at the same time the upper turret's cutting on the main spindle. Now one thing we need to do is we want to make sure we unload the sub spindle before it transfers and goes to the main spindle to grab the part. So I'm going to bring up another utility here. No tool, and I'm going to say unload the spindle in the sub spindle with the parts catcher. You can see you can have a number of choices here depending on your machine. If you have an overhead parts catcher, parts bucket, whatever you'd like. Now the Z position, that sometimes depends on the machine. where you want the sub spindle to go before the parts catcher grabs it. Some can stay at 0, some need to move forward, etc. I just put in 6 inches in here, and we're going to put it about here. Click on do it. Okay, and we can see we have a looks like the parts catcher is controlled by flow number 1, but we want to put this before the sub spindle comes forward because there's going to be material in here already. So I'm just going to move this before the sub spindle comes forward. So now let's take a look at the rendering, see if this has changed some. Okay, turn on our cut part render, rewind. Again, I'm telling Gibbs to stop before any part load, unload, or transfer. So we'll play this. You can see lower and upper turrets doing their thing. All right, now we're going to single step through. So this is where you need to unload the part in the sub spindle, which it does. Now the sub spindle comes forward, grabs, pulls, parts off, and back home. And that's the end of the program EOP. So this is where it'll end, and you'll have a new piece, of course, in the main spindle and can cycle start again. Now we need to look at the sync codes to see how everything looks here, because we want sometimes to put in sync codes to make sure we're not milling or turning at the same time, or we have some things going on at the same time with upper and lower turret when we don't want it to. So we can go to the sync control up here, and you can adjust the operations here. You can tell it to do it by length if you want. This is time, or I like to have uniform boxes here. You can size those up however you'd like. If you click on this checker, this will tell you if everything passes or not, which looks pretty good. One thing I'm going to do though is I'm going to put this should put a sync code in already, but I'm going to make sure it's in there. I want to put a sync between the upper turret and lower turret before the parts catcher comes in. So I'm going to click on this sync button right here and make sure we're on sync control. Click on the bottom of each one of these and click sync, and that puts a hard sync code in your machine, so it makes sure both turrets are finished doing their thing before the parts catcher comes out and drops our part. So that shouldn't really change much in the rendering, but we'll take a look at it anyway. We'll rewind, cut a little bit faster this time. Everything looks pretty good. Everything's finished in the sub. Drops our part off. Sub spindle comes forward, parts off, and back home. Now if you actually want to see the chucks come forward and that, you could always add in your chucks, whether they're collet chucks, 3-jaw chucks. You can import any kind of fixture you would like, chucks and that, if you want to see more of this. You could always do machine sim again if you would like to have Gibbs put a simulation together with your actual machine so you can see the internals of the machine if you'd like to do that as well. But this part looks pretty good right now. So let's look at some code, and I think this is all we need to do on this part. One thing you want to do here, show you a couple things here, is on the sub spindle, you want to make sure you have initial stock and preloaded checked off so Gibbs knows that there is stock already in the sub spindle ready to go when you start machining. And of course the diameters need to be, of course, bigger than we have here. And this part is very important here, this 2.76. This is how much material is actually sticking out of the sub spindle. So remember, we grabbed onto this point here, right at this corner here with the sub spindle, then we did a part pull and parted off. So this is the amount that's sticking out past the chuck on the sub spindle. You want to make sure this is correct here so your rendering looks correct and the G code comes out correct as well. And once you do that, everything should be fine. Now let's look at the G code on here. So I'm going to bring up our post processor. I'm going to click on Process. And it tells me the first operation in each flow must have an Okuma machining mode utility op. Okay, that's fine, and same with flow 2. So we're going to add that in to these two as well, because the Okumas take some special flows. So we're going to put one right at the beginning of flow 1 and one at flow 2. So let's bring up a utility op again. No tool. And we're going to go down to the machining mode. Machine mode. There we go. Then you have a number of choices here depending on if you're doing simultaneous turning, independent machining, alternate machining, etc. We're probably going to do independent machining. Tool group 1, which would be our upper turret, is going to spindle 1. Two group tool to spindle number 2. That looks correct. This is just the time it figures to do the machining mode. You can adjust that as needed. And then, of course, click on Do It. And that should have put our machining modes in flow 1 and flow 2. So now we should be able to post code and be good. You can see the code out to see what it looks like. So let's bring up our post processor. Click Post. And looks good. No alarms here. We'll just kind of scroll down through here. You can see the code here for the main and sub spindle. Everything looks really good there. With that, thank you for watching. Fairly simple to program main and sub spindle with single turret, dual turret, triple turrets, or more, and really easy to do in GibbsCam. Hope you like this video. Thanks for watching.